So going through hypothesis tests for a single proportion, something that we're doing is using our sample data to make claims about our population. So what we're going to have here is some assumed value for our population proportion. And what we want to do is see if our sample value provides evidence that our assumption actually isn't accurate. We're going to try to prove that it's actually larger or smaller, or we can even just prove that it's different. But we need to see how strong of evidence is this value in terms of where it's landing compared to our population proportion. So what we're trying to see is if we build a distribution for how samples should behave for this population proportion, we would see using those sampling distributions, we'd get a bell-shaped curve given that we pass all of those conditions we're looking for. And this is all built around that we have this population proportion. So what we want to be able to do is see these kind of two scenarios come through, where both are built around this assumed proportion. Where is our sample landing? If our sample's landing close by, say our sample lands right here, then our sample's kind of expected in that if this is our population proportion, yeah, there's a high probability of landing in here, and we landed in that region, so this isn't that extreme. So in this scenario, this wouldn't show extreme results, meaning this isn't giving any sort of evidence that this is incorrect. This kind of supporting it, or it matches up with the fact that our population proportion's at least nearby there. So this doesn't show evidence that our population proportion is false. That's something else. What we're trying to do in this section is actually see this scenario where we build our distribution, we have some sample proportion, and say our sample proportion lands out here somewhere, where it's not impossible to occur, but it is extremely unlikely if this is our population proportion. So we build everything around this assumption, and essentially our sample behaves completely different than our assumption. Then what that's giving us evidence for is our assumption's incorrect. Where we see this distribution here, this might be supporting a distribution that's actually further to the right, where this is a more likely occurrence. Yes, this isn't impossible, and with this section we'll talk about the error that comes through that we could be incorrect in our final statement, kind of like how we talked about with 95% confidence, there's this 5% chance that we're actually wrong. We'll have that here. We'll talk about this percent chance that we're incorrect. But these show extreme results because we got this extreme sample that was so unlikely to occur, which, since it's so unlikely to occur, if P is true, if that is our population proportion, that means this gives evidence that that population proportion is false. And what we'll talk about is that we would reject this proportion and say, it may be in this case we'd say, actually that proportion's larger. We wouldn't have an exact value of what it is, but we could say that it should be significantly larger based on this sample result. Whereas if we had this case, it's the idea that it wasn't extreme, so we can't claim that this is any different than where it's landing. It might not be exactly there, but that's where we're not proving what our population proportion is, we're just proving whether or not we have a change. Is it not extreme so there's no change, or is it extreme and there is some change? So what we're going to do is talk through this example and kind of see how these pieces come together, and then we'll talk about these individual pieces a little more in depth.